Hello everyone, let's draw the Lewis structure of BF3, that is boron trifluoride. First of all, we need to count the total number of valence electrons in BF3. Atomic number of boron is 5 and the electronic configuration is 1s2, 2s2, 2p1. 1s2 electrons are core electrons and the 2s2 and 2p1 electrons are valence electrons. So therefore, we have 3 valence electrons in boron, and then atomic number of fluorine is 9 and therefore the electronic configuration is 1s2, 2s2, 2p5. We have 7 valence electrons in fluorine, but we have 3 fluorine atoms and therefore 7 times 3, that is 21, and here it will be 3 times 1, that will be equal to 3. So 3 plus 21, in total we have 24 valence electrons in BF3. Let's write the Lewis structure of BF3 now. Like hydrogen, fluorine atom always comes at the end, and also fluorine is more electronegative than boron, and therefore we are placing boron at the center. Let's place 2 valence electrons each between boron and fluorine so that we can make 3 chemical bonds. We still have 18 valence electrons left, that we can place it as 3 lone pairs each on 3 different fluorine atoms. Therefore, now we have used up all the valence electrons. Now let us check the octet configuration. Each fluorine atom in BF3 will satisfy the octet configuration. However, the boron atom won't satisfy the octet configuration because we have only 6 electrons around boron. This is the reason BF3 is an example of incomplete octet, or we can write the structure this way too. With the 3 chemical bonds, one can place the structure this way too. Now this is the best resonance structure for BF3 because if we try to bring one lone pair to the bond pair, then fluorine atom will have a positive formal charge and the boron atom will have a negative formal charge. For this reason, this is the best Lewis structure for BF3. Now, if we do bring a lone pair to the bond pair and write a resonance structure like this for BF3, it would satisfy the octet configuration because now all atoms have 8 electrons around it. However, this is still unfavorable. We have 8 electrons around each fluorine atom, 8 electrons here, 8 electrons here. Even around boron we have 8 electrons, but this fluorine atom will have a formal charge that will be positive, and this boron atom will have a formal charge that would be negative. Basically, an electronegative atom is having a formal charge of +1 and the electropositive atom will have a formal charge of -1. For this reason, this structure is unfavorable. Let us check the validity of these two resonance structures through the concept of formal charge. Formal charge is equal to total number of valence electrons in the atom minus total number of lone pairs of electrons in the molecule minus total number of bond pairs of electrons by 2. Let us calculate the formal charge first for the structure that has an incomplete octet. So here if we calculate the formal charge for boron, it would be 3 because we have 3 valence electrons in boron minus no lone pairs 0 minus we have 3 bond pairs, so therefore 6 by 2. So this means that the formal charge for boron will be 0 here, and for each fluorine atom it would be 7 minus because we have 7 valence electrons in fluorine and each one has 3 lone pairs, that means 6 here minus it has 1 bond pair and therefore 2 by 2. So this means for fluorine atom also it will be 0. So all the fluorine atoms, the formal charge is 0. In general, if we have even number of electrons in a neutral molecule, we should get formal charges as 0 for each atom. If not, at least the electronegative atom can have a negative formal charge and electropositive atom can have a positive formal charge, but the net should be 0. So in this case we are getting formal charges for all atoms as 0 and therefore the net will be 0. But how about for the structure that is there on the left hand side? If we calculate the formal charge here for boron, it will be 3 minus 0 minus, now we have 4 bond pairs, therefore 8 by 2. So this means 3 minus 4, therefore minus 1. Now we are getting a formal charge as minus 1 for the electropositive atom. That is problematic. And now let us calculate the formal charge for this fluorine atom that is there on top. So here it would be 7 minus, we have only 2 lone pairs, therefore 4 here, minus we have 2 bond pairs now, therefore 4 by 2. So 7 minus 4, 3, 3 minus 2, therefore this is plus 1. For the electronegative atom, we are getting the formal charge as plus 1. That is unacceptable. For this reason, this is an unfavorable Lewis structure. On the contrary, this one is favorable, despite boron having an incomplete octet.